Hello, it's me again. This time we will be solving Big Circle 2 for Chapter 10 review. Please print the material from EDSB and go along with me, okay? Thank you. Now let us label the diagram using the information provided to us. Let's start with the name of the circle, and the name of the circle is Circle M. That makes point M as the center of the circle. Measure of GAF is 25 degrees. That makes this intercepted arc GF, equal to 50 degrees, right? Next, measurement of AKB is 110 degrees. Measurement of arc DE is equal to 60 degrees. And the measurement of arc AG is 80 degrees. Okay. This time, let us make use of diameter GD. We all know that any angle that inscribes a diameter and is an inscribed angle is 90 degrees. That makes angle GAD, this one, 90 degrees. Another angle, GFD, also 90 degrees. Both angles intercept diameter GD. Furthermore, since arc GF is 50 degrees, the associated angle, this is one of the associated angle, is also 25 degrees because this is an inscribed angle and it intercepts arc GF, and therefore half of 50 degrees is 25 degrees. But since this is 90 degrees, that makes 90 minus 25 degrees is equal to 65 degrees. Hence, angle FGD is 65 degrees. Now we are ready to answer the questions. Measurement of GDF is 25 degrees. So this is 25 degrees. Next, measurement of GFD is an inscribed angle that is 90 degrees. That makes this one equal to 90 degrees. Next is measurement of FGD. That is just 90 degrees minus 25 degrees. That makes it 65 degrees. Next is measurement of arc EF. But arc EF is part of the big semicircle, 180 degrees. And this is 50 degrees. This is 60 degrees. So 180 degrees minus 50 degrees minus 60 degrees is equal to 70 degrees. So arc EF is 70 degrees. This arc is 70 degrees. So arc EF is 70 degrees. Let us find the measurement of other angles to be able to answer other questions. First, this angle ADG, intercepts arc AG, which is 80 degrees. That makes angle D or angle ADG equal to 40 degrees, half the intercepted arc. Okay? Next, because this is 90 degrees, then angle AGD is complementary to 40 degrees. That makes angle this one, angle G or AGD, 50 degrees. So this is 50 degrees. And therefore, measurement of arc AD using inscribed angle theorem is twice of 50 degrees, or this one is 100 degrees. So measurement of arc AD is 100 degrees. One of the ways to find the measurement of arc BD, this one, is to use half the sum theorem, because this angle K is inside the circle. So this angle, this remaining angle, which is supplementary to 110 degrees, or this is equal to 70 degrees. So we have 70 degrees is half the sum of 80 degrees plus measurement of arc BD, or 140 degrees is equal to 80 degrees plus measurement of arc BD. And subtracting, that makes it 60 degrees is equal to measurement of arc BD. And therefore, this is 60 degrees. Arc BD is 60 degrees. And the leftover is 100 degrees minus 60 degrees, or equal to 40 degrees. Okay? So, let us answer this, and measurement of arc BD is 60 degrees. Now we want to measure angle C, or measurement of angle BCD. Angle BCD or angle C is the vertex angle is located outside the circle, so we will be using half the difference theorem. Okay, this particular angle intercepts the big arc, arc GE, and the smaller arc, arc BD. This arc is 50 plus 70, and this arc is 60 degrees, and half the difference would be 50 plus 70 is equal to 120. So the difference of 120 minus the smaller arc, which is 60 degrees, is equal to 60 degrees. And therefore, half of 60 degrees is 30 degrees. So this is 30 degrees, and measurement of angle BCD is 30 degrees. Now we find the measurement of angle AHG, and that's this particular angle. This angle is formed inside the circle, so we will use half the sum theorem. So this angle intercepts the smaller arc with measurement of 80 degrees, and the other arc is this one, so big, and that big arc is 60 degrees plus 60 degrees plus 70 degrees, or we have 60 plus 60 plus 70 degrees is equal to 190 degrees, and I will add it to 80 degrees. So 80 degrees is equal to 270 degrees, and half the sum, 270 divided by 2, is 135 degrees. So half the sum is 135, or this angle here that is formed inside the circle is 135 degrees, or measurement of angle AHG is 135 degrees. Now we measure angle GMF. GMF, so let's try to connect point M to point F, and this is a central angle, and this intercepts arc GF with measurement of 50 degrees, hence this is also 50 degrees by definition. Next we measure angle ADE, but this angle ADE is an inscribed angle because D is on the circle, and it makes use of this big arc here that is equal to 80 degrees plus 50 degrees plus 70 degrees. By inscribed angle theorem, I add 80 degrees, 50 degrees, 70 degrees. That makes it equal to 200 degrees. And half of 200 degrees is equal to 100 degrees. So ADE is equal to 100 degrees via inscribed angle theorem. The last two questions have been found already. GAD. GAD, as we know, is 90 degrees because it intercepts a semicircle, and therefore this is 90 degrees. And finally, AKH. AKH, we know, we found it a while ago to be equal to 70 degrees. And that's all, folks. As a summary, we use three important theorems here, okay? First is the inscribed angle theorem, wherein the vertex of the angle is on the circle. Half the sum theorem, wherein the vertex of the angle is inside the circle. And last but not the least is half the difference theorem, wherein the angle is outside the circle. Let us investigate this further. The inscribed angle theorem is to be used when the vertex of the angle is on the circle itself. Measurement of angle 1 is half the intercepted arc, which is x degrees. Measurement of angle 1 is 1/2 of x degrees. Keep in mind that the vertex is on the circle. Half the sum theorem happens if angle 1, the vertex of the angle 1 is inside the circle. And if it's inside the circle, the angle intercepts two arcs, arc x degrees, and the other arc with measurement of y degrees, and measurement of angle 1 is half the sum. Okay? Finally, if the angle is formed outside the circle, it intercepts two arcs, the big arc and the smaller arc, and measurement of angle 1 is half the difference. So we can call the first one the inscribed angle theorem, wherein the vertex is on the circle. The second one is half the sum theorem, wherein the angle is formed inside the circle. And last but not the least is half the difference theorem, wherein the angle is formed outside the circle.